Okay, in this video, I want to walk you through how to find the standard equation of an ellipse and then to graph it. So we're going to use this example, x squared plus 4y squared plus 10x minus 8y plus 13 equals 0. Standard form, remember, looks like x minus h squared over a squared plus y minus k squared over b squared, and that equals 1, not 0. So the first thing that we're going to do, the first thing I'm going to do is move that 13 to the other side, and I'm going to group the x stuff and the y stuff together. So I have x squared plus 10x plus, and I'm going to leave a blank right here, plus 4y squared minus 8y plus another blank. Let's make this one look like this. This equals negative 13 plus that first blank I drew and plus this second blank I drew. Okay, so what are those blanks? Well, what we're going to do is complete the square so that we can write things that look like that. In order to do that, we need to have a perfect square. So we're missing some constant to make these things perfect squares. We're going to figure out what that is. What you're going to do, remember, in a quadratic, standard quadratic form looks like this: ax squared plus bx plus c equals 0. We are going to use b. So we're going to take b. It's going to be b divided by 2. That would be, in our case, with its sign. So in our case, that's 10 over 2, that's 5. Then we're going to take 5 and square it. Okay, so in this blank up here, we get b over 2 squared. In our completed perfect square, it will look like x plus 5 squared. Now, if you do this, x plus 5 squared, that's x plus 5 times x plus 5, which is x squared plus 5x. First outer, inner, last, that is x squared plus 10x plus 25, which is what we wanted. So we have worked that in such a way that we can write that as a perfect square. But because I added 25 to the left-hand side, I need to add 25 to the right-hand side. Okay, we're going to do the same thing with the y parts. In order to do this, though, the a part in ax squared plus bx plus c, that needs to be 1. So we're going to take that 4 out. So we have 4, and then y squared minus 2y plus a different blank. Okay, so now you can do the same thing. We can do b over 2. In our case, that's negative 2 over 2, which is negative 1. Take your b over 2 and square it. So negative 1 squared is 1. The squared part goes up here. Nope. Goes right here. And this part goes, sorry, let's do this one thing at a time. Okay, so because I put this 1 right here, I would then distribute that 4. So I actually added 4 to the left-hand side. So I'm going to add 4 to the right-hand side. Okay, but what goes in the square, the perfect square? It's going to be this guy, b over 2, with its sign. So this would become y minus 1 squared, and don't forget the 4 that was in front. Okay, so then wrapping this, bringing this all down, we have x plus 5 quantity squared plus 4 times y minus 1 quantity squared. This equals negative 13 plus 25 plus 4. That's 16, I think. Yeah, so that's 16. Well, standard form has a 1 on the right-hand side, not a 16. So divide everything by 16. You get x plus 5 squared over 16 plus y minus 1 squared over 4, because that's 4 over 16 would reduce to 1/4, and that equals 1. So a equals 4, b equals 2, right? This is 4 squared, and this is 2 squared. And then we'll find out c in just a minute. So I'm going to go ahead and plot this. Our center of the ellipse is at -5, 1. So I'm just going to draw some axes in and go 1, 2, 3, 4, 5, 1, and there's going to be the center. I'm going to count out 4 in the x direction, 2 in the y direction, and there's my ellipse. And then I'm going to add the foci in just a second. So c squared is going to be a squared minus b squared. So 16 minus 4, that's 12. So c is root 12, which is 3 in sum. So we're going to go out 1, 2, 3 in sum, 1, 2, 3 and sum. And there are your vertices, your foci in here, and your vertices out here, and there's your ellipse.